Variation. Today we are going to look at variation. One thing we have to remember, we have got direct variation, and we have got inverse that variation. Direct variation is like proportional and inverse is like in proportion. So the difference is for direct is both numerator, and for inverse will become a reciprocal or will become a denominator. We have got a few examples explaining to us how we solve problems of variation in both direct and inverse. But before we go on, we have to remember the constant K. The constant K is very, very important. This determines to us how we work out the question. When you look at example 1, you would realize we are given our question statement that involves y and p, and then we are given the value of y. Together we are given the value of p, and finally we are asked to find y when p is 100. The question statement gives us the arrangement of the question. The second part here, that is the values of y and p, help us to find the constant k. And then finally we solve the questions. So let's go together and we see how do we solve these questions. Question number 1. Y varies as p. So that statement could be y varies as p. When y varies as p, we change it to equation and we get y is equal to constant p. Y is equal to constant p. Then y is 10, p is 20 will help us to find the value of k. So when y is 10 is equal to p is 20, that means we have 20k. So we divide by 20 both sides, and finally our k is a half. So after getting k being half, we replace it in our equation statement, and we get y is equal to a half p. So the question now says, find y when p is 100. Find y when p is 100. So basically simplify, and our y is 50. So we get y as 50. Remember, the first part gives us the question statement. The second part helps us to find the value of the constant k. And the third part tells us the final question to solve. Let's look at the second example. There. S is proportional to v minus 4. So we can write this as S is proportional to v minus 4. Remember, this is one item. Then we change it to equation and we get S is equal to k v minus 4. So now our question statement is here. So now we have this second part, that is S is equal to 100 when v is equal to t to 9. We use it to find k. So we shall have 100 as S, and then v is 9 minus 4. So we get 5. So 100 is equal to 5k. So divide by 5, our k will be 20, because 10 divided by 5 is 2. So our k is 20. So after getting k 20, we replace it in our question statement. and we shall get S is equal to, on the place of K, we keep the 20. Then now we solve the question. Find V when S is 200. So S is 200, we need to find V. Okay, here there are many ways. You can divide by 20 both sides and it goes away, or you can open the bracket first and then you work out. So for me, I'm going to divide by 20 both sides. Then this side are left with 10. So 10 is equal to V minus 4. Then I take 4 to the side of 10. It will add because it is subtracting in the question. Then finally, I get my V to be 14. So this is how we solve direct variation questions. First, we must find K, then we use that K to solve the question. So let's look at third question that is taking us to inverse variation. P is inversely proportional to square root of M. So the statement inversely proportional takes us to inverse variation. So P is inversely proportional to square root of M. So that's how we get the statement written. Then we remove and we keep equation is equal to K over square root of M. So we are told P is 25 and M is 4. P is 25 and M is 4. So when P is 25, K over square root of 4 because M is 4. And we know square root of 4 is 2. So times 2 times 2, we get K as 50. So when K is 50, we replace it here. P is equal to 50 over square root of M. Now we need to find M, but when P is 10. So when P is 10, we need to find M. Because M is a denominator, we need to multiply it both sides so that it becomes a numerator. So this side, it will go away. Now I will be left with 10 square root of M is equal to 50 because I've taken square root of M to the other side. So next I will divide by 10, I will divide by 10. I'm left with square root of M is equal to 5 because 0 and 0 is gone. Now to remove the square root, I need to square on both sides. So finally, my M will be 5 square, and that is 25. Let's look at our last example, and this is also inverse variation. Q varies inversely as the square of R. Q varies inversely as R square, because this equation statement says the square of R. So it means R has to be squared. So we change this to equation and we get is equal to K over R square. Our Q is 40 and our R is 2. So that means we have got 40 is equal to K over 4. So to remove 4, we have to multiply by 4 on both sides. And finally, our K is 4 times 4, 16. So 160 is the value of K. So we go to the equation, and we replace K with 160, and we get Q is equal to 160 over R square. Now the question says, find Q when R is 10. So find Q when R is 10. So when R is 10, remember, the equation is R squared. So we shall square 10 and we get 100. So when I have 16 over 10, remove 0, and I get my Q is 1.6. So this is how we solve variation questions, both direct and inverse. Thank you for watching. My name is Mr. Ishengoma.